Hello everyone, welcome to Module 6 of Climate Change course. In this module, we will discuss about the international organization that play a critical role in climate change study. In particular, we will be discussing mainly about the International Panel on Climate Change and the resulting climate change scenario that they have identified. So in general, you will learn about several topics including the international organizations that have been working on climate change and related concerns. And you will also learn about climate change scenario and its development progress, and also the projected future climate condition. So by the end of this module, you should be able to describe the importance and role of international organizations in addressing global climate change issue. And you should also be able to identify some important source of climate data, explain about different climate scenarios developed by the International Panel on Climate Change, and describe about the expected climate change under various scenarios. We understand that climate change is not the issue that happens in just any particular region of the world, but it is the global concern. It happens and impacts on every part of our planet. Therefore, to address climate change concern, it is beyond one nation capacity, and it is the responsibility of every country. So as a matter of fact, it is not easy for multiple countries to work on the same direction without having a proper binding treaty of cooperation and collaboration. In that sense, to understand climate change as to combat its impact, it is necessary to have various international bodies or organizations that can bring all the countries to work together. So far, to the present day, there are many international organizations that have been formed to address climate change concerns. Some of the well-known organizations include the United Nations Environment Programme, the World Meteorological Organization, the United Nations Framework Convention on Climate Change, and the International Panel on Climate Change, and so on. But here we will only discuss about the International Panel on Climate Change, which are shortly called IPCC, and the World Meteorological Organization, which we can call in short WMO. Both organizations are very important international bodies that play a critical role in climate change assessment. The IPCC is the leading international body which synthesizes and assesses climate change knowledge. It was established in the 1980 by UNEP and WMO. The more important role of IPCC is to assess or peer review and publish climate change information. So since the beginning of its establishment in the 1988, IPCC has brought many number of climate change scientists, biologists, economists, sociologists, etc., from every continent to work together and to produce various reports on the state of knowledge of climate change science, analyze the impact of climate change on socio-economic and ecological systems, and identify possible adaptation and mitigation options to fight this global change. These reports are very important for all nations as it provides key scientific information for developing climate policy and key input for the international negotiation. So to the present day, IPCC have already published many types of reports, including the assessment report, special report, methodology, and technical paper. So the assessment report covers the review of the latest science on climate change impact, vulnerability, adaptation, and mitigation options. So until now, there are already 5 assessment reports that have been published, with the most recent one was released in 2014. And the next one will be released around 2020 or 21. The special report, on the other hand, are the report that focus on selected topics. For example, on the renewable energy resource, extreme event and disaster, emission scenario, and so on. The methodology and technical paper are the guidance document which provide comprehensive explanation on the technique and methodology that have been used and should be used for climate change assessment. Another important international body that helps us understand climate change is WMO. WMO was established in 1950 and became a specialized agency of the United Nations in 1951. Its mandate is in the area of meteorology and operational hydrology and also related geophysical science. So after its establishment in 1950, WMO have played a unique and powerful role in contributing to the safety and welfare of humanity by bringing up the collaboration between the national meteorological and hydrological service of its member country and expanding the application of meteorology in other areas. So in terms of climate change, WMO plays a leading role in providing the physical and meteorological information that are necessary for climate change investigation. So currently, WMO runs a number of programs, including the Global Climate Program, that provide policymakers and scientists with important knowledge and information, which help them to ensure successful response to climate change. Those programs generally aim to produce better accuracy of climate change prediction and projection, to develop operational structure to provide climate service globally, and to develop an essential global observing system to meet climate information needs. One of the example of the program is the Global Climate Observing System, which is a service running under the World Climate Program and supported by various organizations. The main role of this program is to ensure that climate observation around the world are accurate and sustained, and that access to climate data is free and open for everyone. So this program contributes to resolve the challenge in climate investigation and also underpin the existing global climate service and adaptation measure. Another example is the Global Atmosphere Watch program. The main role of this program is to provide reliable scientific data and information on the chemical composition of the atmosphere, its natural and anthropogenic change, and help to improve the understanding of the interaction between the atmosphere, the ocean, and the biosphere. So under this program, climate data and related information are collected through a global monitoring network of more than 80 observation stations from all around the world, as you can see in the map on this slide. Thanks to the effort of many international organizations, our capacity to understand climate change has been improved over time. So a lot of necessary information about climate change and related concerns include the biophysical change, the observed and predicted impact and vulnerability, as well as adaptation and mitigation options are now available and can be obtained from various resources. Showing in this slide are the name of some important international organizations and programs where you can go through to look for different types of climate data and climate change information. So for example, from the IPCC website, you can obtain various reports on the overall progress of climate change science, the summary of the observed climate condition, and also projected climate at different scale. From various programs of WMO, you can get the observed record of atmospheric parameters from various parts of the world. And similarly, different types of observed climate data can also be obtained from NASA and ESA, especially the data that collected by the satellite system for large-scale and long-term assessment. The UN Climate Change Learning Partnership, on the other hand, is a learning resource that provides comprehensive online courses on various topics, which can help you to better understand about climate change and other related concerns. So if you are keen to learn more about any specific topic, please go through the website of this international organization and program. There are a lot of useful information that you can get from them. So now let's move to climate change scenario. So basically, climate change scenario or climate scenario are the plausible representation of future climate conditions projected under various scenarios of greenhouse gas concentration. They are generated by the global climate models as the response of climate system to different level of greenhouse gas concentration that result from the variation in socio-economic setting, which include population level, type of economic activity, the structure of governance, social value, and also pattern of technological change. So in general, climate scenarios are developed to use for investigating the potential impact of anthropogenic climate change as to inform policymakers to be prepared for future risks and to plan for appropriate mitigation action. So in that sense, it is very crucial to have the most accurate climate scenario as possible. And the key to have better accuracy of climate scenario is to have an appropriate greenhouse gas emission scenarios. For the effort to have the best prediction of future climate change, the International Panel on Climate Change has released different series of greenhouse gas scenarios, which were periodically improved and used in different assessment reports, as you can see in the table on the left side of this slide. So the two widely known scenarios were the Special Report on Emission Scenario, or shortly called SRES, which was published in 2000, and the Representative Concentration Pathway, or shortly called RCP, that are released in 2009. So while the SRES focus only on the level of greenhouse gas emission at a particular period, the RCP estimate also the temporal variation of greenhouse gas emission over time, and that lead to the accumulation of greenhouse gas at the end of the century. The figure on the right side shows the summary of SRES scenarios. These SRES assume different increase in greenhouse gas emission in the future based on different socio-economic storyline, which lead to 4 scenario family, including the A1, A2, B1, and B2 family. Basically, these 4 scenario family assume the future of the world with different demography and socio-economic tendency. So for instance, the A1 family assumes that future world will have a very rapid economic development with low population growth and rapid introduction of new and more efficient technology, especially in the energy sector. On the other hand, the A2 family assumes that future world will be characterized by a rapid population growth and a regionally oriented economic development that make technological change very fragmented and slowly progress. The B1 and B2 family, on the other hand, are different from A1 and A2 family, as they also put an emphasis on environmental protection and sustainability, both at local scale and global scale. So based on these 4 socio-economic storylines, about 40 emission scenarios were developed and assumed to be equally plausible. These scenarios were very useful for climate projection in the 3rd and the 4th IPCC assessment report. Somehow, these SRES still have a lot of limitation and uncertainty, given that they were developed solely based on the snapshot of socio-economic assumption and without considering an ongoing change and the effect of climate policy that happen continuously over time. So later on in 2007, there is a call for improvement of greenhouse gas scenarios, which also emphasize the ongoing change of the system under the influence of scientific advancement, global change policy, as well as the effort to mitigate greenhouse gas emission, impact adaptation, and vulnerability, which provide a better representation of actual change mechanism. So resultantly, in 2009, IPCC released a new set of scenarios known as the Representative Concentration Pathway, or RCP. So rather than focus on a snapshot of greenhouse gas emission in a specific future time, as in the SRES scenarios, the RCP provides a time series of greenhouse gas emission and concentration trajectory that lead to achieve certain level of greenhouse gas and radiative forcing over a long timeline. So the current RCP scenario describes the concentration pathway of greenhouse gas up to the end of the 21st century, with 4 most plausible scenarios. This scenario includes the RCP 2.6, which is the mitigation scenario that leads to a very low radioactive forcing level. So under this scenario, greenhouse gas emission will be aggressively mitigated so that substantial amount of greenhouse gas will be reduced over time. Then the RCP 4.5, which is a stabilization scenario, which radioactive forcing is assumed to be stabilized shortly after 2100 due to strong mitigation action. Then the RCP 6.0, which is also a stabilization scenario, for which radioactive forcing is assumed to be stabilized by adaptation of some technology and strategy for reducing greenhouse gas emission. Then the RCP 8.5 is a very high emission scenario that characterized by an increasing greenhouse gas emission over time without any mitigation effort. This diagram depicts 4 potential climate futures according to the RCP scenario that you have seen in previous slide. So basically, what climate condition we would face in the future depending on how much effort and what mitigation action or policy we will adopt to cut down the level of emission. So according to this diagram, under the very intensive mitigation action of the RCP 2.6, greenhouse gas emission will be reduced to about 50% of current rate by 2050. And if this scenario is achieved, by the end of this century, the global warming is unlikely to exceed 2 degrees Celsius compared to the pre-industrial condition. Under this scenario, business activity are governed by climate policy that lead to reduce substantial amount of greenhouse gas emission with additional effort to have negative emission or to remove carbon dioxide from the atmosphere. In contrast, under the RCP 8.5, business activity will be operated without additional mitigation action that we are doing today, which means that it will be shaped by the impact of climate change. So for this scenario, greenhouse gas emission is expected to continue to rise at current increasing rate until the end of the 21st century. The global warming is predicted to be just below 4 degrees Celsius compared to the pre-industrial period. In that case, severe impact of climate change that might be irreversible are expected to strike our Earth system. Then for the 2 stabilization scenarios, including the RCP 4.5 and RCP 6.0, business activity are expected to be operated with various mitigation action and policy. Under these scenarios, our Earth system is likely to increase its average temperature by around 2 degrees Celsius, which is the warming threshold that can lead to potential risk of extinction for many species. And this level of warming have marked the first global warming target for the 21st century. Somehow, many studies have suggested that to be able to achieve sustainable development goal, the global warming rate must be limited to well below 2 degrees Celsius or just around 1.5 degrees Celsius. So now let's discuss about the potential change in the climate system under different RCP scenarios. Showing in this graphic is the trend of projected change in surface temperature under different RCP. So overall, we can see that global surface temperature change for the end of this century is likely to exceed 1.5 degrees Celsius relative to the pre-industrial level for all RCP scenarios, except for the RCP 2.6. Furthermore, it is likely to exceed 2 degrees Celsius for RCP 6.0 and RCP 8.5. And according to the third IPCC assessment report, under these scenarios, approximately 20 to 30% of the living species are at increased risk of extinction. In addition, food security and human health will be threatening. For instance, crop productivity, especially for cereal, in the low latitude region would significantly decrease. and the distribution of vector-borne disease, for example, those diseases that are transmitted by mosquito and rat, is also likely to change both in terms of location and timing. The increase in the Earth's surface temperature always accompanied by many other variations and abnormalities. According to the IPCC climate projection, it is estimated that over the 21st century, the contrast in precipitation between wet and dry season and wet and dry region will increase, which means that there is an increased risk of both drought and flood around the world. Furthermore, extreme precipitation events are likely to become more intense and more frequent over most of the mid-latitude landmass and the wet tropical region. So the map in this slide shows the average change in precipitation pattern by the end of the 21st century compared to the average level between 1986 and 2005 under the RCP 2.6 and RCP 8.5. So based on this map, under a low emission scenario of RCP 2.6, change in annual mean precipitation will not exceed 20% compared to the 1986-2005 level. However, under the RCP 8.5, significant change in annual precipitation are to be expected. The high latitude and the equatorial Pacific Ocean will experience an increase in annual mean precipitation, while in many mid-latitude and subtropical dry regions will have a decrease in mean precipitation. Under climate change scenarios, change in the ocean surface pH is also expected. So at the present day, the average ocean surface pH is about 8.1, but according to the IPCC climate projection, ocean pH is expected to drop over the century due to the increase in atmospheric carbon dioxide concentration. The map on this slide indicates the projected change in ocean surface pH under the lowest and highest emission scenarios. So it is suggested that under the lowest emission scenario of RCP 2.6, the ocean pH will drop very slightly, which means that the ocean acidification will be limited. However, under the highest emission scenario of RCP 8.5, the global average ocean pH will drop between 0.30 and 0.32 unit. Such a progressive acidification of the ocean water will threaten marine creatures, especially the species that form shell and carbonated skeleton, for example, coral and the other species that depend on them. Similar to other parameters, mean sea level is also expected to increase globally. The result of IPCC climate projection suggests that under the impact of global warming, global mean sea level will continue to rise over the 21st century. In general, under all RCP scenarios, the rate of sea level rise will exceed the observed rate from 1971 to 2010 due to the increase in ocean warming and increased loss of ice mass from the glacier and ice sheet. So in particular, as can be seen in this graphic, the projected rising rate range between 0.26 meter to 0.98 meter, depending on scenario. And this expected sea level rise have put a great risk of permanent inundation to many coastal cities around the world. So now we have reached the end of Module 6, and until this point, you should have learned that the international bodies such as IPCC, WMO, and others play a critical role in climate change assessment and mitigation globally. It is impossible to improve our understanding on climate change and to combat it without having a proper binding treaty of cooperation and collaboration among international. Climate projection is very important for investigating the potential impact of anthropogenic climate change, as to inform policymakers to be prepared for future risks and to plan for appropriate mitigation action. To have a reliable climate projection, appropriate emission scenarios are required to be periodically updated to take into account the influence of scientific advancement, recent emission information, existing impact, vulnerability, adaptation, and mitigation policy. The resulting climate projection indicate that By the end of the 21st century, climate change impact will strike everywhere on Earth. Without proper mitigation action, global surface temperature change is likely to reach about 4 degrees Celsius. Significant change in annual precipitation are to be expected. Global surface ocean pH will drop between 0.30 to 0.32 units, and the global mean sea level can be as high as 0.98 meter. But with the aggressively mitigation action, global surface temperature change is very likely to be less than 2 degrees Celsius. Change in precipitation will be about 20%. Ocean acidification will be limited, and global mean sea level can be lowered to around 0.26 meter. So now we can call it a day, and I will see you again in the next module.